Right, doing an inference test, first we need to decide what type of inference test we should be running here. We're going to read through the problem, and the two questions we're going to keep in mind are going to be, are we constructing a confidence interval or are we testing a hypothesis? And then are we going to have one sample or two samples? Right, keep those things in mind while we read through this problem, and that will help us determine what type of inference test we will be running. So let's read through this together. According to a large poll in a previous year, about 80% of homes in a certain county had access to high-speed internet. The following year, researchers wanted to test if less than 80% of people had access to high-speed internet. They took a random sample of 250 homes from that county and found that 189 of them had access to that internet. So, first, we're going to decide, are we creating a confidence interval or are we testing a hypothesis? Look for those key words, confidence interval and test. Those will clue you in as to which one we are doing. Here it tells us in sentence number 2, the following year, researchers wanted to test if less than 80% of people had access. So they are testing a hypothesis. We are going to be in the testing a hypothesis right-hand side of our table. And now we need to know, is it one sample or two samples? There's only one sample that's mentioned here. They took a random sample of 250 homes. So there's just one sample. Do not be confused by this 189. That is the proportion of success that is taken from that sample. There's only one sample here that was taken. There's no other group of homes that we are comparing. So this is a one proportion hypothesis test. So we'll go here, hypothesis, one sample, and we are in the proportion part of things because there are going to be no means on this test. You can always just go straight to proportions, but also we can look in the problem. And since we are talking about the percent of people here, that would be a proportion. It's not a mean, that's what proportion of people had access. So it is a proportion. That means that we are going to be performing a one prop Z test, a one proportion Z test, one proportion hypothesis test. If you look in the study guide, you will see the template for this that you can use, and we're going to fill out that template now together. You'll see it labeled as the hypothesis test for one proportion. In that first box, we're going to put the test name. We just decided it's a one prop Z test. It's going to ask you for a couple other pieces of information in that box. It'll ask you for the P naught, and it'll ask you for your null and alternative hypotheses. So the P naught here is going to be what we've assumed, the proportion that we've assumed to be true up until this point. It is going to be 80%. 80% of people have had that access, so 0.8 will be our P naught. And we have to describe what that is to the AP graders, give it some context. So I will go in the problem again. And I will say, what was that 80% describing? It was describing how many homes had access to that high-speed internet. So the proportion of homes with access to high-speed internet. If identifying P naught is easier for you by looking at the null hypothesis first, you can do it this first and then fill in your P naught. It doesn't matter what order you do it in as long as all of the information is on the paper. Null hypothesis is always going to have our P being equal to something. Our P naught is going to be equal to that 0.8, always going to be an equal sign. The alternative hypothesis, it's going to be either less than, greater than, or not equal to, depending on what we are trying to claim in the problem. So here it says they are testing if it is less than 80%. So I'm going to say less than 0.8. And that will be all of the things I'll put in box 1. Box 2, I'm going to check those conditions. I'm actually going to skip checking the conditions for this one because I showed in the In the confidence interval for one proportion, I showed checking conditions for one proportion. So reference that video if you'd like to see how to do this. It'll be the same thing, but just applied to this problem. We're going to skip to box 3. It's going to be calculator talk. It's a one proportion, one prop, the test. And we're going to tell the AP graders what we put in our calculator. It's going to ask us for the P naught, the X, and the N. P naught we already found in box 1 is going to be 0.8. X and N is going to be when we go out into that real world and take the sample to see what's really going on. That'll be the number of successes in that sample and the sample size. So if I look in my problem, it says they actually went out and took that random sample of 250 homes, and 189 of them had high-speed internet. So the proportion of success, or the number of successes here, our X value, is 189. The sample size was 250. They had 250 homes that they sampled from. So that will go into our calculator. And this part you do not have to write on your paper, but it asks you what your null or what your alternative hypothesis is. So it asks you, is your alternative hypothesis not equal to, less than, or greater than? And you'll just match this part up with whatever the alternative you wrote was. So here it's less than, we use less than. Do not have to write this on your paper. You can if you want, you don't have to. Okay. So we run that test in the calculator. Let's do that here. To get to it, we go stat, over to tests, down to a one proportion, a one prop, z test. I'm going to tell them my P naught is 0.8. My X is 189. My sample size is 250. Less than is going to match up with my alternative hypothesis. I will calculate and get a p-value out. My p-value here is 0.041. And then I'm going to see, is that based on my cutoff point here, my alpha, am I going to accept or reject the null hypothesis? If the problem does not give you an alpha, which this one doesn't, it doesn't tell us what confidence level to be at, we're going to be at 0.05. Based on that, in box 4, we're going to interpret this p-value. That's everything that we need to put in box 3. Box 4, we have to decide, is our p-value less than alpha or greater than alpha? 0.041 is less than alpha. So we are going to use that first template in the box 4. Let me pull that up here. Okay. So our p-value of 0.041 is less than the alpha of 0.05. Therefore, we can reject the null hypothesis. We reject the null because that p-value is just the likelihood of the null hypothesis. If that p is really low, below our cutoff of alpha, that means it's very unlikely the null is actually occurring, and we're going to reject it. That means we do have evidence then of the alternative. So we do have evidence that, and here we're going to describe our alternative hypothesis, was that P naught is less than 0.8. So we're going to say that in context of the problem, less than 80% of homes in the county have access to high-speed internet. And that is all of our parts for this FRQ. One small correction on this. These should not be P naught, these should just be P. That's my mistake. These should not be P naught. They should be P, and this number is actually P naught that we're comparing them to.